In this video, I want to explain something that usually confuses students, and that is that a single vertex is a connected graph. So what I'm saying is if I just draw a dot and I give it a name, say capital A is a connected graph. You think if this is the graph G, this is a connected graph. So let's see why. So it all comes down to a few definitions. First, a graph is connected if for all A, B in the vertex set, there's a path from A to B. So maybe let's look at that a little bit. Let's say that, for example, we have this graph G that is just, looks like so. A, B, C, D. So this graph is connected because no matter which two vertices you pick, now I think this is one thing that kind of bothers people, is that we don't mean literally that there's vertices that are labeled A and B. These are just placeholders. They mean that for any two vertices that you pick, there's a path between them. So notice how in this graph here, this graph right here, no matter which two you pick, there is a path between them. And okay, well, what is a path? Well, here's the definition of path here. Remember that a path is from vertex A to vertex B is just a walk from A to B, where the defining sequence has no repeated terms. Okay, so a path from vertex A to vertex C would be A, B, C. That's a path from vertex A to vertex C. All right, and so now, with that in mind, now we can look at just a graph that is a single vertex. Let's say this graph is a single vertex A, labeled A. This is the graph G. So this graph is connected if no matter which two you pick, there's a path from A to B. No matter which two you pick, there's a path between them. Okay, so let's say we pick two vertices at random from the vertex set, which is literally just the set A. So if you pick two things from there, I know you're saying, well, you can't pick two things from there. Well, it's kind of like sampling with replacement or something like that. You know, so you pull something out and you say, okay, this is what I have in my hand here. And then you put it back and then you pull something else out. So if we pull any two of them from there, right, then we would pull A twice. So then we would have A, there's a path from A to B, and that's just a sequence that starts at A and ends at A. There's no repeated, so then this would be your path written in sequence form. The sequence is that. And that is a path, that is a walk from A to A, where the defining sequence has no repeated terms. I mean, there's no repeats there. So yeah, a single vertex is a connected graph.